So this is the quiz, and I'm going to work the problems out as if I were taking it as a student and what I would be thinking. So as I looked at the first question, I hopefully would remember the limit as h approaches 0 of f of x plus h minus f of x all over h is what I mean when I say the definition of the derivative. And then I have to apply it to this particular problem. So that would be the limit as h approaches 0 of the function, which is right here, evaluated at x plus h, meaning the x is coming out and the x plus h is going in its place. And what a lot of people forgot is that means you're doubling x plus h before you add on the 1. That's how you evaluate it at x plus h. Minus the function just as I gave it to you, all over h. And then after that was done, then you should have realized, oh, this is one of the problems where we use the conjugate. So in order to be able to plug 0 in for h, I have to be able to divide this h out. And the way that happens is we multiply by this thing called the conjugate. So it is the exact same thing in the numerator other than the sign in between. The square root of 2 times the quantity x plus h plus the square root of 2 plus the square root of 2x plus 1. Oh, sorry, and I have a plus 1 in here that I have to put in there. So again, it's the square root of 2 times x plus h in parentheses plus 1 plus the square root of 2x plus 1. When you multiply by the conjugate, you should realize that it's a very simple process of taking this radical times that radical, leaving you with what's underneath, minus, then you take this radical times itself again, and you're left with 2x plus 1. It's in parentheses because I have to distribute my negative. It's all over h. So then I still have not taken the limit, so I'm going to keep writing it. But when you distribute through here, you should realize you get 2x plus 2h plus 1 minus 2x plus 1, which means the only thing left on top is 2h. And in the denominator, I just realized that I forgot to write my conjugate down here. I can't forget that. When I multiplied h times the denominator, the conjugate should have been down there. So my denominator has the h and the conjugate. And then the numerator, this h can divide out with that h. And then once that's done, I can actually take the limit, meaning I can send the other h to 0. And that leaves me with 2 up top and the square root of 2x plus 1 when this h becomes 0, plus the square root of 2x plus 1, which is the same thing. And that leaves you with 2 times the square root of 2x plus 1. And then you can divide out your 2's and get all the way down to your final answer. And yes, that is a lot of work, but if you had practiced it and worked on it, it should not take you an inordinate amount of time. And then you would automatically know, I'm going to use the conjugate, these things are going to multiply, these things are going to divide out. It's going to be a really quick process. So on your review sheet for the requiz, you want to be able to deal with the definition if you have a square root, which is when you use the conjugate. But probably since it's a requiz, you're going to not be asked the exact same type. So remember that you also might have a fraction. So if I made the function 1 over 2x plus 1, you'd have a fraction where you'd have to use a common denominator. And the other option is I could take 2x plus 1 and square it, where you have to expand out your square So those were the only 3 types that we had to do. You, on this quiz, had a conjugate, but on the next quiz, you probably will have one of the other 2 types. So just be prepared. Then we got into find the simplifying and the derivatives. So what I noticed on most people's papers is they didn't take a time to say what rule they were going to use. So in this case, you have one function here times another function here. And whenever you have 2 functions multiplied together, you have to use the product rule. So you have to know what the product rule says. What the product rule says is if you have one function here called u and another one called v, in order to take the derivative, you want to leave u alone and multiply it by the derivative of v, and then add on v left alone times the derivative of u. So in this case, for the derivative, you should have left 2x squared plus 1 cubed alone and multiplied on -5, which is the derivative of v. Then you should have left the -5x plus 2 alone and multiplied on the derivative of u. Now here's the tricky part, is you have to remember that when you take the derivative of u, you need the general power rule. So you bring the 3 down, that's your exponent. You do not change your function, that's on the inside, but you change the exponent on it to 1 less. And then you also have to remember the chain rule. So you multiply by the derivative of this function, which is 4x. So taking the derivative of the u function here was a little tricky. You had to know to use the general power rule. Now I said simplify, and what I mean by that, as we said over and over, is you want to factor out any common factors. And in this case, the common factor was 2x squared plus 1, and you want to pull it out to the lowest degree. Then you write what's left, which before the addition, which is right here, you're left with another 2x squared plus 1 and a -5. After the addition, you're left with your -5x plus 2 and a 3 times a 4x, which we can combine up to 12x. And then you need to distribute and combine inside the brackets. So if you distributed here, you'd have -10x squared plus -5. And here you'd have -60x squared plus 24x. And when you put it all together, 2x squared plus 1 squared, combine your x squareds, -70x squared plus 24x minus 5. Again, the beginning of the whole thing is what rule am I going to use? And the same thing is true on 2b. For 2b, you have to look at that and say, I need the quotient rule. And I know I need the quotient rule because this is a binomial and I can't simplify it to avoid it.